Hi friends, in this video we are going to see how to get the total equivalent resistance for the given network. Okay, so in the previous videos we discussed about how to calculate the total resistance when resistances are connected in series and in parallel. So if you know about that concept, then only it is possible to understand, otherwise it is not possible. Okay, so now come to the question number 1. Okay, so the question number 1 is find the total resistance for the below network. Okay, so question is find the total resistance for the below network, and here add some sentence across the terminals A and B. Okay, now this is a question, and here the network is like this. For example, this is terminal A we are calling, and here resistance is connected like this. For example, connected like this, and here one resistance is connected across these two resistances, and one other resistance is connected here. And for example, this is assume terminal B, and for example, and one more resistance is connected here, another one is connected here, and across these three resistances one more resistance is connected like this. Okay, now what I'm doing, I'm giving the names for all resistances. Now see, for example, the value of resistance R1, this one is for example 1 ohm, and for example this is R2 is equal to 1 ohm, R3 is equal to 1 ohm, and this one assume R4 is equal to 1 ohm, and this one R5 is equal to 1 ohm, and here R6 is equal to 1 ohm, R7 is equal to 1 ohm, R8 is equal to 1 ohm, R9 is equal to 1 ohm, and this is the last resistance R10 is equal to 1 ohm. Okay, for example, in this network we have total 10 resistances, and in this 10 resistance we have individual value for individual resistance. Okay, now what is actually our question? The question is to find the equivalent resistance across equivalent resistance or total resistance, both are same. Okay, so the question is to find the equivalent resistance across the terminal A and terminal B. It means what? So please remember, when terminals are placing in the left side, then always you have to reduce or find the value of total resistance from right side. It means what? Terminals are in the left side means you can start from right side. For example, terminals are available in the right side means you can start reducing the network from left side. Okay, so this is a very important key point. Okay, now see here, before we are going to reducing the circuit, what I am doing here, first I am going to identify which resistances are connected in series and which resistances are connected in parallel. If you know about the exact series and parallel connection of the resistances, then only it is very simple to find the total resistance across the terminal A and B. Okay, now see here, we already discussed about the series and parallel connection of resistances in previous videos. Okay, just to go through all the videos and come to this video, then only you can understand very well. Okay, now see here, in the given problem, R9, R8, R7, these three resistances are connected in series. Okay, these three resistances are connected in series, and here R2, R3, it means what? These two resistances are connected in series. Now what I am doing, first I am going to find the resultant of these two connections. After finding these two, what I am doing, I am replacing the resultant value in the actual network. Okay, then you will get exact solution. Okay, now see here, the step number 1 is R2 and R3 both are connected in series. Okay, so both are connected in series. Now we know that when two resistances are connected in series means, so we can directly add those particular two resistances to get the total resistance. Yes or no? Now here, for example, R10 is the last value, and what I'm doing for simplicity, the combination of R2, R3 we don't know exactly. So that's why what I'm doing, I'm giving the name for the new resistance as that is R11. So R11 is equal to R2 plus R3. Okay. Now we know that the value of R2 is 1 ohm plus R3 is also 1 ohm. Now here the unknown resistance, that is new resistance, R11 is equal to 2 ohms. Okay. Now this is the value of this combination. Okay. Now we know that the series combination of R2, R3 will gives 2 ohms. Okay. Now coming to the next combination, that is what? The combination 2 is, yes, now we are taking the step number 2. Now step number 2 is what? R7, R8, R9 all are connected in series. That is what? R7, R8 and R9 are connected in what? In series again. Now again we know that when resistances are connected in series, we can directly add what? The combination of connection. Okay. Now here R11 is the new resistance, and here the combination of R7, R8, R9, what I'm doing, I'm considering the name or giving the name as R12. Okay. Now R12 is equal to what? R12 is equal to R7 plus R8 plus R9. Now here R12 is equal to, the value of R7 is 1. R8 is also 1. R9 is also 1. It means R12 is equal to 3 ohms. Okay. Now see here, R11 is the resultant of R2 and R3. R12 is the resultant resistance of R7, R8 and R9. Now what I am doing, I am replacing these two values instead of the series combination. Okay. Now see here, I am just placing here. Now see here. So this is terminal A and this one is terminal B. Okay. Now here, this one is the R1 value 1 ohm, and instead of R2, R3 we got the value of what? R11. So R11 is equal to 2 ohms, and here what? Now here this one is what? Just see here. So this one is R5. After this one we have another resistance, that is R5. R5 is also 1 ohm. Now what is the next one? R6. So R6 is connected here, and this one is also, R6 is also 1 ohm. Okay. Now what is the next combination? Now see here, R7, R8, R9, instead of the series combination of these three resistances, we got the value of what? R12 is equal to 3 ohms. Now instead of the series combination, I can directly place the value of R12. Okay. So that is the reason why what I am doing. So this one is R12. R12 is equal to 3 ohms. Okay. Now across this R12 we have another resistance. Okay. Just see here, across the combination we have another resistance, that is what? R10. Okay. Now see here, this value is what? R10. R10 is also 1 ohm. Okay. Now see here, R1 is as it is, and combination of R2, R3 will give the value of R11. That's why I am placing R11 is equal to 2 ohms, and across R11 we have another resistance, that is what? R4. So here one more resistance is connected across this particular new combination, that is R4 is equal to is also 1 ohm. Now see here, so this network will becomes like this when we are going to finding the value of series combination of resistances. Okay. R2, R3 will gives R11 value, R7, R8, R9 will gives the value of R12. Okay. Now what we are doing, now again observe here. Now here by observing, just see here, R11, R4 both are connected in parallel. Okay, R11, R4 are connected in parallel, and here again one more combination, that is R12, R10 are connected in parallel. And we know that when resistances are connected in parallel, we can take what? Reciprocal of the resistances. Okay, so here the step number 3. So step number 3 is R4 and R11 are connected in parallel. So in parallel, then how to find the equivalent resistance for this parallel combination? We can directly take the reciprocal of the resistances. So reciprocal of total resistance 1 by RT is equal to what? 1 by R11 plus 1 by R4. Okay, now here 1 by RT is equal to, we can simplify here. So 1 by RT is equal to, take LCM R4 into R11, and the numerator we will get R4 plus R11 by simplifying. Okay, this is 1 by RT is equal to this expression, but we required what? Only resistance, total resistance. Okay, now this total resistance is equal to, take the reverse, that means what? You will get R4 into R11 divided by R4 plus R11. Okay, now we know that the value of R4 and R11. Now here the total resistance RT, we can give another name for the new combination. Our new value is what? For example, R12 is also already over, that's why I'm giving the name for this one is R13. So R13 is equal to R4 into R11 divided by R4 plus R11. Now substitute the value of R4 and R11. R4 is how much? R4 is 1 into R11 is how much? 2 divided by R4 is 1 plus R11 is how much? 2. Now here R13 is equal to 2 divided by 3 ohms. Okay. Now 2 divided by 3 ohm is the value of what? R13. Okay. Now this value is clear. Now here one more combination is there. One more combination. What is that? Another combination. The another combination is what? R12 and R10. So here the another combination we need to find, that is what? The step number 4 is R10 and R12 are connected again in parallel only. So in parallel. Now again and again, no need to go for this step. Reciprocal of total resistance is equal to reciprocal of R11 plus reciprocal of R4, like this. Okay, so again and again, no need to go for like that, because finally we are getting the expression is what? Whenever the two resistances are connected in parallel, we can directly take the product of two resistances divided by addition of two resistances, like this. Okay, so that is the reason why here we are calculating the value of R10 and R12. So that is the reason why the unknown value or new value R14 is equal to so R10 into R12 divided by R10 plus R12. Now we know that the value of R10 is 1 ohm, R12 is 3 ohms divided by 1 plus 3. So that is equal to R14 is equal to 3 divided by 4 ohms. Okay. Now here the value of R13 we know, and the value of the value of R14 also clear. Now we know that, so 2 by 3, how much you will get the value? For 2 by 3 you will get 0.666 ohms. Okay. So for example, this is the value of R13 is equal, by solving you will get the value of R13 is 0.666, and coming to the value of this 3 by 4 you will get what? By solving this you will get, so R14 is equal to 0.75 ohms. Okay, now R13 is the parallel combination, resultant of the parallel combination of R4 and R11, and R14 is the resultant of the parallel combination of R10 and R12. Now what I am doing, again I am going to placing R13 value, R14 value in the actual network. Okay, now what will happen? Just see here. Now see here, this is terminal A and we have the value of resistance, that one is R1 here, 1 ohm, and here another resistance, that is the value of what? R13, I think. Yes, this is the R13 value. So here R13 is equal to 0.666 ohms, and here the value of R5. So R5 is equal to 1 ohm, and here we have the value of R6. So R6 is equal to again 1 ohm, and just see here the parallel combination of R10, R12, we got the value of R14, that is what? 0.75. Now we can directly place this particular 0.75 instead of the parallel combination, that is R14 is equal to 0.75 ohms. Okay, now see here what is happening here. Just see, when we are going to finding the value of total resistance across this terminal A and B, so finally we are simplifying the total network, and finally we are getting the total network in series form. Just see here, so R1, R13, R5, R6, R14 all are connected in series. Now we know that, so the last step is what? Step number 5 is R1, R13, R5, R6 and R14 all are connected in series. So all are connected in series. Now the final total resistance across the terminal A and B is equal to addition of all resistances, that is what? R1 plus R13 plus R5 plus R6 plus R14, that is equal to the value of R1 is 1 ohm, the value of R13 is 0.666 plus R5 is again 1 ohm. Next R6 is also 1 ohm, R14 is 0.75. So like this we need to do the calculation when all are connected in series. Now what is the last step? We need to add all these values. Okay, now see here, 1 plus 1 plus 1, it means what? 3, and 0.666 plus 0.75, it will give what? 1.416, that is equal to 4.416 ohms is the value of total resistance across the terminal A and B. Okay, so this is the procedure we need to follow whenever we are going to getting the equivalent resistance or total resistance in the given network. Okay, so thank you so much for watching, and please do subscribe my channel for more updates. Thank you so much.